Hi everyone. So this is the last part for this module, and it will be about scheduling and irrigation scheduling. So let's look at scheduling. So the aim of irrigation is to fill the soil water to such an extent that optimal crop production is possible due to a poor climate. So what you want to achieve with irrigation is that if your climate doesn't provide enough rain or enough water for you to have an optimal crop production, you need to start irrigation scheduling or applying irrigation in order to have that crop production. And efficient irrigation requires measuring the crop's needs and providing the right amount of water at the right place at the right time. So firstly, you need to know what the crop's needs are, and then you need to apply the right amount of water at the right place at the right time. So um, if I can sketch this, you've got this crop, and there's the soil, and now you've got your roots. So firstly, you need to know what this crop's what it needs, how much water it needs, and then you look at the root system. So if you've got two different kinds of crops, maybe you've got one like this, and this one has a very deep root system, whereas this one has a lot of shallow secondary roots at the top, but it's not that deep. This one will have a longer cycle, so you'll allow the water to filter deeper into the soil, but the space, the area that you need is a lot smaller, whereas this one, you'll apply your irrigation at a wider area. So this area is a lot bigger than this one, but shorter cycles. So that's why it's important to know what the crop needs, but also to know where to put it and what time, how long, but also during what phase of growth. So especially for most crops, from bloom to harvest or fruit growth, that's when a lot of water is required. And then supplementary irrigation, just to make a distinction, is when you only irrigate during dry climatic conditions or certain growth stages. So if you are situated in a climate, maybe like the Western Cape, where you don't get a lot of rain during summer, if you only irrigate during the summer or only during a specific growth phase, then that is seen as supplementary irrigation. Then under irrigation, so it's when an insufficient amount of water is supplied, and you'll have a small harvest and low harvest quality because your harvest isn't getting enough water. And then over irrigation, it's excessive amount of water, so you applied too much water, and now your roots don't have oxygen, and that leads to root damage and diseases, especially diseases like Phytophthora, soil-borne diseases, and you'll have a low harvest quality because your plant isn't getting enough oxygen. So that leads to the question, how much water should you apply? When do you apply it, and how do you apply it? So when we're looking at scheduling, there are four different factors, main factors, influencing the amount of water to apply. Firstly, it's the climate, then it's your plant, your irrigation system, and then lastly, your soil. So the factors that influence the amount of water to apply, if we're looking at the climate, that refers to the effective rainfall. So effective rainfall is the amount of water that actually falls on the soil. Sometimes you have a lot of, you're in an environment with a lot of evapotranspiration, so that's not effective, or a lot of runoff, or especially interception if you've got thick foliage or very large leaves. Your water doesn't necessarily end up on the soil, and the plant is unable to use that water. So that is seen as that is not seen as effective rainfall. And so then you have the main thing after effective rainfall, evapotranspiration, and that is influenced by all these following things: radiation, so that's the amount of energy from the sun. You can imagine in summer, you've got a lot of energy from the sun reaching your crops, and so you lose a lot of water due to evaporation. Sunshine duration, so in the summer you've got longer days than in the winter. Higher temperatures leads to more evapotranspiration, low humidity, and then high wind speeds. And that all influences the amount of water that you should apply to your crops. Then your plant. So we all know that you require water for photosynthesis. So plants require a lot of water, and specifically in some stages more than others, especially if you think of bloom and fruit growth, or in earlier stages during physical vegetative growth. Your plant needs a lot of water for photosynthesis to provide energy, so then your plant will require a lot more water. The volume of the roots and effective root depth. So if I can still use these two, so when you've got this kind of root system that's really thick or that's really deep, you require a long period, so a long duration of irrigation in order to effectively reach the bottom. And then as opposed to, let's make this number 1, and then as opposed to number 2, where you have a shallow or smaller root system. And because of that, then you require a lot less water or shorter cycles, especially. So knowing your root system and what the plant needs for that root system is important. Then your irrigation system, as was said earlier in the year, a drip system is a lot more efficient than something like a center pivot. So that will influence the amount of water that you apply. And then lastly, if we're looking at the soil, so obviously something like your soil texture plays a big role, your clay versus sand. But then also, if we get down to the detail of it, you've got field capacity and your permanent wilting point of your soil. So if you remember from soil science, field capacity is the amount of water that you can apply. So this is our y-axis, the amount of water. Then your field capacity is the amount of water that the soil can hold before the excess water is leached or removed due to gravitation. So at the amount of water at the top here, you have your field capacity. Then at the bottom, you've got your permanent wilting point, so PWP, and that is the little amount of water in the soil before your plant starts wilting. So in between that, we've got the soil water capacity and the total available water. So total available water is this area in the middle. Okay, so this is the available water, and that's between field capacity and permanent wilting point. So soil water capacity refers to the size of your soil reservoir, and then total available water is that water that's available between your field capacity and permanent wilting point. So at the bottom here, we see this formula, and that refers to your readily available water, in Afrikaans, maklik beskikbare water, and that is basically the water that's available to your plant. So you calculate that by taking your soil water capacity. So that's that SWC or waterhouvermoë times by your ERD, and that is the effective root depth. So for different crops, that'll be different. So in Afrikaans, that EWD effectieve worteldiepte, and then you've got that alpha sign. So that's the maximum amount of water that can be extracted, and that then is the maximum amount of water in your soil that your plant can extract, and that is a fraction. So that is how you calculate readily available water, and I think that's enough for this video.